was on number systems.
Okay, so what are number systems? A number system is a set of symbols that are used to identify the quantity of something and are used for the basis of counting. So, for example, when you're teaching your students how to count to 100, skip counting by 2s, skip counting by 5s. Also, number systems are important for comparing amounts, performing calculations, and representing value. So, for example, if you have the number 10, and you want to represent that number, there are a few different ways that you can represent it. So 10 could be 2 less than 12. So 10,
You want this one?
that's not really working. Two less than 12. 10 can also be 5 more than 5.
And it also can be represented in any form of math. Addition, subtraction, multiplication, division, any type of equations that you want to set it up in. Number sentence, word problem, number system kind of carries over throughout all of the curriculum.
And also 5 plus 5 equals 10. So you can see that there are a lot of different ways that you can represent the value of 10. Also, it's important to have students learn about the structure or properties rather than specific numbers because this process enhances the student's understanding of the number system and allows room for other mathematical exploration.
Our objectives. So first, we want to be able to understand the basic properties of the number system and all that embodies it. We want to be able to describe the importance of fractions in everyday use. That objective is more directed towards our actual 5th grade lesson for today. Define equivalent fractions and give examples. Recognize fractions that are equivalent. And lastly, manipulate materials to show several examples of equivalent fractions, which is a part of the activity we will be doing today as a class.
Okay, so past research. Past research has suggested that the structure of properties is vital in the number system, such as the commutative or order property for both addition and multiplication. So if you take a look at 394 plus 176 equals n plus 394, students would usually say that n equals 176 because 394 plus 176 is the same as 176 plus 394. Students also, when they attempt to prove that something is true, it's a relatively new and interesting field in research. As early as 2nd grade, students have the competency to prove their own conjecture is true. So, for example, for multiplication, if you have 41 times 3 equals 3 times 41, students would generally all agree that this is true. So when you're making conjectures in class, you shouldn't always respond with an answer, but you should respond with questions such as, is this always true and how can we find this out?
Properties of the number system. Properties of the number system range from, as we said before, addition and subtraction, multiplication and division, to conjecture, which are conjectures derived from basic properties. These properties can be shown as the sentences such as a plus 0 equals a minus 0 equals a times 1 equals a, along with a divided by 1 equals a. Then the next one would be a plus b minus b equals a, and a times b divided by b equals a.
Okay, so what is a fraction? So without looking up here, everyone, what is a fraction? Everyone should go. Good. So, a fraction is a part of a whole, and it is the parts that result when the whole or unit has been partitioned into equal sized portions or fair shares.
Then we'll go into children's. Okay. Children's understanding about fractions. Children seem to understand that the idea of separating a quantity into two or more parts to be shared fairly among friends. They eventually make connections between the idea of fairly among friends, meaning being able to take a piece of cake and dividing it so that everyone gets an equal share. They eventually also make connections between the ideas of fair share and fraction parts. This is something that you guys are actually going to be doing today as a class.
Okay, and then another form of fractions is equivalent fractions. So what is an equivalent fraction? An equivalent fractions are fractions with the same value but a different look. So for example, 50 over 100 is also equal to 1/2.
Can somebody else give me an example of an equivalent fraction besides 50 over 100 and 1/2?
25 over 100 and 1/4.
Anything else? There's a million out there. Dana?
75 over 100 is 3/4.
Good. And understanding equivalent fractions is critical because it's a way of describing the same amount.
So to now get into our lesson for today, the standards that we're following are creating equivalent fractions given a fraction and comparing fractions using equal sign. So who likes pizza? Huh?
Who wants some pizza?
We were going to get you guys real pizza because like last time we did our project we brought in cookies because it was the cookie problem, but there was like no place open at 11 o'clock in the morning to get you pizza, so I'm sorry. Oh, who wants some pizza? So here we have our pizza boxes with pizza. Yeah, it's little personal pan pizzas. And I have tape over here. Yep. So what we're going to do is set up 3 different pizza pies on the board and have volunteers come up to make equivalent fractions. Okay, we're going to attempt to. They're scrumptious. So we're going to have teams of 4. So the 4 of you are going to be one team, this 4 is going to be another, and this 4 is going to be one. Okay? So first we're going to have one member from each team, or yeah, 3 teams. You guys are going to each be assigned a pizza pie. So group 1, which is Brittany's group, is going to have this pizza. Group 2, which is Dana's group, is going to have this pie. And Lindsay's group is going to have the 3rd pie. So if we need one member from Brittany's group to come up and take away 2 slices from their pizza pie.
Be the representative of this my group. Okay.
That's one. So now there's 2 slices taken away from that pie. What is the fraction of what is left? Or how many slices have been taken away in fraction form? Group 1. 2/4. Okay, group 2. Can somebody come up and take 4 slices away from your pie? take four slices out.
Okay.
Now, how many,